a sequence H set to be Cauchy convergent if for a given epsilon greater than 0 there exists n greater than equal to m intersection p greater than equal to 1 such that this is followed: Sn plus p minus Sn, the mod of this is less than epsilon, where epsilon is any positive number no matter how small you take. No matter how small you take, if a sequence S is convergent, if a sequence S is convergent, then you will always be able to, let's say this is the number line on which we are representing natural number 1 2 3 4. You will always, sometimes if it is m1 m2, you will always be able to find this m1 m2 m3 if you go beyond these three numbers, these aims, then this Sn plus p minus Sn will be less than epsilon. You will always, if the sequence is a convergent sequence, then you will always be able to find aims. You will always be able to find m's, and if you take n which is coming after m, so you will always be able to find m for which Sn plus p, where n will be greater than m and p is greater than equal to 1. You will always be able to find such that the difference between Sn and the Sn plus p, the extra steps that you have taken, let's say if Sn is here and Sn plus p is here, then this difference will be less than the distance between two will be less than epsilon if the sequence is convergent. The n will be sufficiently large, obviously, so that the gap between these two, the Sn plus p and the sequence that you are getting after including n plus p terms, minus after having n plus p terms, minus the sequence which is having n terms, if the gap will be so narrow that it will come down to less than epsilon. So this is what Cauchy says. Then the sequence will be a convergent sequence. Here in this, what people find challenging is that proving if some sequence is not Cauchy convergent. Proving if a sequence is not Cauchy convergent. Let us understand this by a question. So students generally find it challenging. Students find it challenging to prove that a given sequence is not Cauchy convergent. Let's talk about this. Let's say the sequence that is given is Sn is equal to 1 plus 1 by 3 plus 1 by 5 plus 1 by 2n minus 1. This is the sequence. and we have been asked to prove that not Cauchy convergent. It is not Cauchy convergent. So what Cauchy says is that if we are taking a sequence with n plus p terms, we have a sequence of n terms, right? Sum of the terms is n, and then we are taking few more terms, that is p more terms, and then this is the sum Sn plus p on the number line. Then if this n is greater than or equal to a particular m is a number, a particular m, and p is greater than equal to 1, so this distance will be less than epsilon. If we are able to figure out this m and this m, right, then we are done, right? We are done proving that Sn plus p minus Sn is less than epsilon, right? We have this, epsilon is given, we have this inequality, and if we are able to find this m for which this inequality holds, then we are done, right? We are done. We can say simply that this is Cauchy convergent. Right? But if somehow we are able to prove that sum of n plus p terms and the difference between sum of n plus p terms and the sum of n plus n terms is greater than a particular epsilon, greater than an epsilon, some epsilon, if we are able to arrive at this, it means that for some given epsilon, this inequality is not holding, right? This inequality is not holding. It means this implies that this is not Cauchy convergent. True? Correct? So far so good. So when we have to show that a particular sequence is not Cauchy convergent, then this much is sufficient for any of the epsilon. If we find that the difference is not narrowing down, the difference between these two for large n, it is not narrowing down for any epsilon, then we can simply say that this is not Cauchy convergent, because the difference is not the sequence, the sums are not coming closer, they are apart from each other by a certain length. They should be coming closer, the difference between two should be less than epsilon for any infinite small epsilon value. Now let's look at this Sn. Sn is given as 1 plus 3 plus 1 plus 5 plus dot plus 1 by 2n minus 1. If I take Sn plus p, how will it look like? It will look like this: 1 plus 1 by 3 plus 1 by 5 plus dot 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 plus 2 n plus p minus 1. This is how it will look like. If you take the difference Sn plus p minus Sn, mod of that, how it will look like. So the term before 2 of n plus 1 minus 1, the terms, all the terms before this term will be cancelled out because we are taking the difference, and this will continue to go up to 2 into n plus p minus 1. Now look at this expression. Look at this expression. If you're going to prove something, that this is not Cauchy convergent, already you have been told that this is not Cauchy convergent. Hence, we try to find this epsilon for which this is greater than this number. No matter how much you try, how far you go in term on the natural number line, how far you go Sn plus 1, no matter how much you extend Sn to n tends to infinity or whatever, you will, the gap between these two will not come closer than epsilon, right? Hence you are done, right? If the gap is not closing down, it means the sequence is not converging. Convergence means simply that the gap should come down, right, between the Sn and the Sn plus p. So can we write this? Just look at this. We can always write such kind of expression as this is greater than 1 by twice of n plus p minus 1 plus 1 by twice of n plus p minus 1. All the terms, I am converting all the terms, replacing all the terms with 1 by 2 n plus p minus 1, because all the terms will be greater than or equal to this term 1 by 2 into n plus p minus 1, right? So 2 n plus p minus 1. How many of these terms will be there? These are p terms, right? Just why I'm doing this, because what I saw is that in the denominator this is linear in n. This is linear in n, and we also know that if I combine these terms by replacing the terms with a smaller number, so if I combine them, add them, we can get something linear in numerator as well. And if we are having something linear in numerator and something linear in denominator, then we at large value of n will always be able to find some number, existing number, right? Some defined number. So this is what I am trying to do. This will be n plus p minus 1, right? Let's say p is twice of n in one condition. If this is to be Cauchy convergent, this has to be true for all the conditions. Even if this fails, even for one condition, that is our particular case of p is equal to n, even if it fails for this particular case, that is of p is equal to n, why I am taking this p is equal to n is because then I can easily calculate this expression. I am converting this expression to one single variable. We have right now two variable, so I can take any of the p which is greater than or equal to 1. Let's say for the time being we are taking p is equal to n, because if this is Cauchy convergence, this has to be true for p is equal to n also, that this is the difference between 2 Sn plus p minus Sn, the modulus of that should be less than epsilon. If this is becoming greater than epsilon for any epsilon value, for a particular case, that is p is equal to n, then for all the cases where p is equal to n, this will be greater than epsilon, hence will not converge. So here we have 4n minus 1, and this is nothing but greater than n by 4n, right? We can cancel it out. So Sn plus p minus Sn is greater than 1 by 4 in a particular scenario where p is equal to n, right? And let's say if I take this as epsilon also only, because this has this should, this, if they had been convergent, if the sequence had been convergent, then the difference between Sn plus p minus and the Sn, the difference between Sn plus p and Sn should have been less than epsilon for any of the epsilon, no matter what you take. For epsilon is equal to 1 by 4, if the difference is greater than epsilon, when p is equal to 1, it means the sequence is not coming closer when we are taking more and more terms. Hence, this is not Cauchy convergent. So point is that what you have to understand here is that you take any epsilon. How you solve the problem is that you take any epsilon greater than 0, and this has to be obviously epsilon has to be obviously as small as possible to understand if the sequence is converging. You take any epsilon for which this inequality is being satisfied, that is Sn plus p minus Sn. You write this inequality and you try to arrive at this n greater than equal to m, that is you find this m for which this is true, for which this is true, then you will be able to say that this is Cauchy convergent. That's it. Thank you.